Today, I have a tool here that is often misunderstood by some of the reviews I've seen about it on YouTube. This is the Uni-T UT501A insulation resistance tester, and I'm going to show you what it is and why you would want it, and why it's actually an essential tool for checking wiring. Now, I've seen all kinds of different reviews of people doing different things with these things, and they do have several uses. I've seen people use them on circuit boards, and I could see something for that. They are also used to test multi-phase motors, so you can see if they've gotten wet or something like that, if the windings are contacting each other and all that kind of stuff. But today we're going to concentrate on using it as a wire tester, and we're going to be looking for broken wires and faults. And I'm going to show you why the test isn't necessarily as simple as you would think. So this tester is designed to be used as a 1-2 punch with a multimeter. And this is the Mustool MT108T. It is my throw it in the bag cheap multimeter that I got from Banggood. This also came from Banggood. They sent me this for free. I did a review on this a while ago. I've got a separate video on that. But we're talking about this primarily today. But you can't really use this without this. And so there's a two-step process that I want you to understand, and we're going to demonstrate it. And the first step involves continuity testing. So I have a piece of wire here, and this wire in reality would normally be 100 feet long because you're in a house, and you've run this wire and it's been through some stuff and you don't know if it got cut, you don't know if something got broken. The code requires that, obviously there not be cuts and nicks in the wire and things like that, that there not be any circuits to ground that shouldn't be there. So you need to run a test. Now these tests are designed to be run before this wire is energized, before this wire is hooked to its final equipment. We need to check the integrity of the wire. Now, so if this was, let's say a 30-meter wire, you're not going to run your meter probes. You don't go buy 30-meter meter probes. So what you generally do is on the far side of the wire, you will take, let's say we're going to take the neutral wire and connect it to the ground wire. Again, we're not connected to anything. And you're going to bust out your multimeter. Now, the first rule of this is know thy multimeter. So we're going to turn this meter on, and you're going to see that right now it is just saying 0L. So in other words, you want to know what your multimeter is going to display if nothing is connected. That's important information because in the event that this wire is broken, you want to know what it's going to display. And then you also want to do a test where you connect these wires together and you see what it looks like when there is a solid connection. So 0, 0, 0. Now, if there was some resistance, it would read, see that 0.01 or 0.1. So anyway, know your multimeter. And then the obvious test that you're all familiar with is we're going to take the meter and we're going to connect it to both sides of these wires. And we're going to test to make sure that we have continuity. Now, this one's auto-ranging for a second, but you can see we're getting, just over an ohm and a half, but we have continuity. Now, there is another mode that you can put it in where if you were to hit the select, it'll put a little speaker up there on the screen, and you can actually hear a beep. And you can do the same thing there and make sure you're getting your beep and that there's a good connection there. And then you would do the same thing between the ground and the neutral. Okay, so now that we've done the familiar continuity testing, we're going to look at the Uni-T UT501A. And we need to do the same know your meter thing. And this may seem dumb, but you want to understand what happens if there's no connection and what happens if there's a perfect connection so you know what you're reading. So the first thing we're going to do is we're going to take these probes, make sure I'm not touching anything because we're going to be putting out 500 volts at 1 milliamp. So not enough to kill me, but enough to make me feel it. Now, these voltages are not arbitrary. When you are doing household, testing, the rule of thumb is if you're doing less than 300 volts, so your normal household wiring, whether you're in a 120 volt or 240 volt country, you want to test at 500 volts on your giga-ohm test. And if you are doing wiring up to 600 volts, so if you're in a factory, you got some 4-phase or 3-phase wiring, stuff like that, then you want to test at 1,000 volts. So we're going to do the residential test at 500 volts, and I'm going to hit this button. and you'll hear the thing is making a nice little coil whine, and it shows here that we are putting out 524 volts, and this thing, it has a reading of 5.5 gigaohms. So in a perfect world, we have, if there's no connection between the wires, we will see something in the range of 5.5 gigaohms. Now, we're going to do something that would seem a little crazy. We're actually going to connect these things together here. And the reason why we're doing that is it theoretically could have a break right here in the wiring that is shorting the two together. So we want to know what happens if you have a perfect connection. And so we're going to hit the button, and you hear all kinds of buzzing and beeping and all that stuff. And we had 0 mega ohms and yeah, just a dead short. So you know that things are going to go a little wild if we have a dead short. So what we're going to do is we're going to hook this thing up. Now you'll notice I have removed the alligator clips because the point of this is for there to not be a connection. So we're going to connect up, doesn't really matter which side. We're going to connect up here, and we are going to do the 500 volt mega ohm test, and I'm going to push the button, and you'll see that we are getting the perfect 5.5 mega ohms, 525 volts coming out of this thing. There is no connection between these wires, and that's exactly what we would expect. But now we're going to do some more creative tests. And now I'm going to demonstrate to you why this test and this test are designed to be done together. You know, one of the things, we often don't think about multiple points of failure. One of the reasons Chernobyl happened is because they thought, this, and this all can't go wrong at the same time. But the reality is that's what happens. And we often don't plan for that, and we pay the price. So what I've done is I've set up my continuity tester just like before, and I'm going to do a continuity test. And as you'd expect, everything works just dandy. Now, imagine we have two things. Imagine, let's just go ahead and say that this wire got cut somewhere or broken somewhere, and you know, you would do your continuity test and nothing do it. And you'd think, okay, well that's great. So, you know, we know that wire's broken. But what if somewhere in the construction process, somebody had driven a nail or a screw or something like that through the Romex? I've obviously removed the Romex to make it easier to see what's going on. But let's say somebody had driven this nail in here and connected these wires together. So we're going to simulate that. So as you can see over here, I have my cut wire, and this alligator clip isn't connected to anything, but I come over here to do my continuity test, and we still have continuity. And that's because two things went wrong at once. So we have a broken wire, but that broken wire is short-circuited somewhere else to my return. And so I would have no way of knowing that. Now, if I ran the ohm meter a lot, I might know how many ohms about 100 feet of wire should give me, and I might be able to detect it because I got a lower resistance than I probably should have, but that is not an exact science. So what we're going to do is we're going to hook up the Megahmmeter resistance tester, and we're going to turn it on to 500 volts, which is what we should turn it on for a residential test of less than 300 volts on the line. And we're going to push the test button, and you can see immediately this thing is going crazy, telling me that we have a fault. And that is what makes this tool special. It takes a combination of continuity and insulation resistance testing to ensure that you have a good connection. I'm going to do another test that would be impossible to do with a multimeter. Let's say that you've pulled some wire through a conduit and the wire has snagged on the end or something like that and ripped a little bit. That obviously would not fail any kind of continuity test or anything like that. But let's say you get a call a couple months later saying that every time it rains, my pump trips, or every time it rains, such and such happens, or when it gets real humid out, this happens. Well, what I've done is, instead of using a piece of conduit, I've put a pan and I've put just normal tap water, just simulating rain. And it's not uncommon at all for pieces of conduit to fill up with water. It happens all the time. And as you can see here, I am not reading any continuity between the pan and the wire. So as far as this thing goes, there is no connection. But if we were to hook up the insulation resistance tester by putting one connection on the piece of conduit and the other one on your wire, you'll see that as we bring it up here, this wire is a solid centimeter off the bottom of the pipe. So there's no physical connection between them. But if I were to bring this up to the 500 volts, this is standard for residential voltage testing, and we push the button, you can see this thing is freaking out, and we have a connection between the, let's say, conduit and the wire. So without the insulation resistance tester, there would be really no other safe way to conduct that test to figure out if there's some kind of bridge between your conduit and your pipe underground. My overall impression of this unit is that it is a quality unit, and it is basically what I would call Uni-T quality. So this is way better quality than your normal cheap, just knockoff item. It's not going to be like a Fluke or anything like that, but it's not priced like a Fluke. It's $77 to $80. Comes with a set of leads. It has these nice screw-on alligator clips. It comes with a case. It's also a tool that you're probably not going to use on the bench as much as you'll use in the field. So I appreciate that it has this nice hard cover in here to protect the screen, even if you don't want to put it in the case. And there's a strap around here, so if you need to carry it over your shoulder like a Merce, you can do that. Thing takes 6 AA batteries, which should give it decent runtime and all that. And overall, it's a quality device that you're not going to find just walking down the aisle of your Home Depot or from your normal electric supply. You got to get it from a place like Banggood. And so I do recommend it. Thank you for